Good morning, vibrant city of Valenzuela. I am Oliver G. Mariana from Citero Francisco Memorial National High School. Together, let's learn more in mathematics here in another episode of Valenzuela Live, your live streaming school. Are you ready? Let's start. In this session, we will be dealing with Lesson 5 of the third quarter, which is about solving word problems involving permutations and combinations. At the end of this session, you are expected to meet the most essential learning competency of Week 5, Quarter 3, which is to solve problems involving permutations and combinations. Let's begin our lesson with a simple recall of the difference between a permutation and a combination. A permutation is an arrangement of objects in which order is important, while a combination is an arrangement of objects in which order is not important. As defined previously, let's see if you can identify whether a situation illustrates a permutation or a combination in our first activity entitled React on Me. If you think that the situation illustrates a permutation, hit the Wow React button. But if it illustrates a combination, hit the Heart React button. You will be given 10 seconds to think about each situation. Is that clear? All right, here is the first one. Forming a committee with 4 members from 10 students. You have 10 seconds. Go. Time is up. The given situation illustrates combination. Let's proceed to the next one. Drawing the 6 winning numbers in the 645 Mega Lotto. 10 seconds. Go. Okay, time's up. If you hit the Heart React button, then you're right. Let's go to the next one. Selecting 3 balls from a jar with 8 balls. You have 10 seconds. Go. Time's up. If you hit the Heart React button, then you're right. It illustrates combination. Let's go to the next one. Arranging 6 students in a row for picture taking. Your 10 seconds starts now. All right, if you hit the Wow React button, then you are correct. The given situation illustrates permutation. Let's proceed to the next one. Picking 2 fruits in a basket. 10 seconds, go. Okay, time's up. If you hit the Heart React button, then you're right. Let us proceed to the last one. Placing books in a shelf. 10 seconds, go. Okay, time's up. If you hit the Wow React button, then you're right. Good job, grade 10. I think you can still clearly distinguish whether a situation illustrates a permutation or a combination. Now, to help you further in the next parts of this lesson, let's take a closer look at this table. Most of the time, a permutation problem contains the word arrange, place, assign, and the like. Also, it concerns arranging objects, digits, people, letter, numbers, and many more. Whereas a combination problem often contains the word choose, select, form, pick, draw, list, or other words that are essentially of the same context. To make our approach in solving word problems involving permutations and combinations systematic, we follow these steps in solving a word problem. First, understand the problem. Then, devise a plan. Next, carry out the plan. And last, look back. Are you now ready to sharpen your analytical and critical thinking skills? Great! Here is sample problem number 1. In how many ways can a presenter, timekeeper, and recorder be assigned for an online class activity attended by 12 students? First, we understand the problem. Does the problem require permutation, combination, or both? Okay, the problem requires permutation. How many students are in the class? Yes, there are 12 students in the class. How many tasks have to be assigned? All right, there are 3 tasks to be assigned. Then, we devise a plan. Our plan is that we compute for the permutation of 12 taken 3 at a time to get the number of ways in which the 3 tasks may be assigned. Then, we carry out the plan. Computing for the permutation of 12 taken 3 at a time, we have 12 factorial divided by quantity 12 minus 3 factorial. Subtracting 3 from 12 gives us 12 factorial over 9 factorial. We may write 12 factorial as 12 times 11 times 10 times 9 factorial. By cancellation, we obtain 1,320. Last, we look back. Have we executed our solutions as planned? Is our obtained answer reasonable? Hence, we can say that there are 1,320 ways in which a presenter, timekeeper, and a recorder be assigned from among 12 students. Let's have our next sample problem. Sample problem number 2. How many plate numbers can be made by arranging the symbols FUD696? First, we understand the problem. Does the problem require permutation, combination, or both? Yes, you're right. The problem involves permutation. How many symbols do we have to arrange? There are 6 symbols to be arranged. In this problem, we know that there are 6 slots for the given symbols to be arranged, in which the first 3 slots are allotted for the letters F, U, and D. Since each letter is distinct, we treat this as a permutation of n objects taken R at a time. Further, The last three slots are for the digits 6, 9, and 6. Obviously, there are symbols here that are alike. So, we treat this as distinguishable permutation. Now, we devise a plan. Our plan is that we compute separately for the two different types of permutation and get their product. Continuing, we carry out the plan. So we have the permutation of 3 taken 3 at a time times 3 factorial over 2 factorial. For the permutation of the letters and digits respectively, this is equal to 3 factorial times 3 times 2 factorial all over 2 factorial. Evaluating further results to 6 times 3, which is equal to 18. Now, we look back. Does our answer look sound? All right. Therefore, there are 18 other possible plate numbers that can be made from the rearrangement of the symbols FUD696. Let's take another sample problem. Sample problem number 3. 3 couples have bought tickets to a concert. Their seats are next to one another in a single row. If each couple sits side by side, how many seating arrangements are possible? First, we understand the problem. Does the problem require permutation, combination, or both? Good. This problem requires permutation. How many couples are there? Okay, we are given 3 couples. How many persons are there in a couple? Right, there are only 2 persons in each couple. To picture out and further understand the problem, let's look at this one. Suppose these are the seats allotted for the 3 given couples. Since each couple sits side by side, one possible arrangement is that the first couple occupies the first 2 seats, followed by the second couple, and last by the third couple. So here, we can see that because couples are always together, it seems like we are arranging only 3 persons, 3 at a time. Note also that each couple may be seated in 2 ways. Now, next is we devise a plan. Our plan is to compute separately for the 2 different permutations involved and get their product. Now, we are ready to carry out the plan. We have the permutation of 3 taken 3 at a time times 2 times 2 times 2. Wherein the permutation of 3 taken 3 counts the number of arrangements of the 3 couples who are to be seated side by side. And each 2 represents the number of ways in which the persons in each couple may be arranged. This expression is equal to 3 factorial times 8. But the value of 3 factorial is 6. So we have 6 times 8, which gives us 48. Looking back, we have carried out the steps correctly. Nice. Thus, we can say that there are 48 possible seating arrangements. Let's move to our next example. Sample problem number 4. A box has 3 chocolate bars, 4 marshmallows, and 2 candies. In how many ways can 2 items be picked from the box? First, we understand the problem. Does the problem require permutation, combination, or both? Good. The problem involves combination. The order of taking two items from the box is not important. How many items are in the box? Yes, we are given a total of 9 items in the box. How many items should be picked? All right, we need to pick 2 items. Then we devise a plan. That is, we compute for the combination of 9 taken 2 at a time to get the number of ways in which 2 items may be picked from the box. Now, we carry out the plan by solving for the combination of 9 taken 2 at a time. Using the formula for combination, we have 9 factorial over quantity 9 minus 2 factorial times 2 factorial, which is the same as 9 factorial over 7 factorial times 2 factorial. This may be expressed as 9 times 8 times 7 factorial divided by 7 factorial times 2 factorial. Simplifying, we have 36. Looking back, have we executed our solutions as planned? Very good. Hence, we can say that there are 36 ways in which 2 items may be picked from the box. Let's proceed to our next problem. Sample problem number 5. How many different polygons can be made from 5 distinct points on a plane with no 3 of which are collinear? First, we understand the problem. Does the problem require permutation, combination, or both? Nice. The problem requires combination. The order of choosing the points needed to form a polygon is not important. How many points are given? Correct. We are given 5 distinct points with no 3 of which are collinear. What are the minimum and maximum number of points needed to form a polygon? Very good. In this problem, we can form a polygon using a minimum of 3 points and a maximum of 5 points. Recall that to form a triangle, we need 3 points for its vertices, while to form a quadrilateral, we need 4 points for its vertices, and to form a pentagon, we need 5 points for its vertices. Then, we devise a plan. That is, we count the number of triangles, quadrilaterals, and pentagons that can be made and add all these results. Now, we carry out the plan and we begin by stating that the number of triangles plus the number of quadrilaterals plus the number of pentagons is equal to the number of polygons. To form the desired polygon, we choose the corresponding needed number of points from among the given points. Counting them, we have the combination of 5 taken 3 at a time for the number of rectangles, the combination of 5 taken 4 at a time for the number of quadrilaterals, and the combination of 5 taken 5 at a time for the number of pentagons. Evaluating, we have the combination of 5 taken 3 is equal to 10. The combination of 5 taken 4 is equal to 5. And the combination of 5 taken 5 is equal to 1. Adding these 3 values gives us 16. Looking back, were we able to do all the previous steps correctly? All right. Thus, we can conclude that There are 16 different polygons which can be made from 5 points on a plane, no 3 of which are collinear. Let's have our last problem. Sample problem number 6. From the 10 members of a department, a committee consisting of a chairperson, a vice chairperson, and 2 other members has to be formed. In how many ways can this be done? First, we understand the problem. Does the problem require permutation, combination, or both? Nice. The problem requires both permutation and combination. Which part of the problem requires permutation? Correct. Assigning a chairperson and a vice chairperson involves permutation. Which part of the problem requires combination? Good. Choosing 2 other committee members involves combination. Then we devise a plan. That is, we compute separately for the required permutation and combination, then take their product. Now, we carry out the plan. First, we compute for the number of ways in which we can assign a chairperson and a vice chairperson. Since there are 10 members in all and there are 2 positions to fill in, then we compute for the permutation of 10 taken 2 at a time. This is equal to 90. Next, after we have assigned the chairperson and vice chairperson, we now proceed to choosing the 2 other committee members. At this point, we only have 8 members to choose from. Consequently, we solve for the combination of 8 taken 2 at a time, which has a value of 28. Multiplying, we obtain 2,520. Looking back, have we obtained a reasonable result? Nice. Therefore, we can conclude that there are 2,520 ways to form the desired committee. Now, let's have our second activity entitled Minute to Get It. I'll be posting a word problem and you will be given 1 minute to solve it. Once you're done, key in your answer in the comment box. Here is the first one. From the letters of the word water, how many arrangements can be made if all the vowels and all the consonants are together? You've got 1 minute, go. All right, time's up. The correct answer is 24. Let's now proceed to the second one. 5 representatives to a seminar must be selected among the 7 math teachers and 8 science teachers of Payapa High School. In how many ways can the selection be done if there must only be 2 science teachers. 1 minute, go. All right, time's up. The correct answer is 980. Let's now move to the last one. In a pageant with 10 semifinalists, 5 finalists are chosen to answer in the Q&A portion, out of which the winner, first runner-up, and second runner-up will be crowned. In how many ways can these events happen? All right, time's up. The correct answer is 15,120. Now is the perfect time to reflect on what we have learned today. As students of New Normal, you need to set up your priorities in order to successfully move to senior high school. In this table, you can see that your tasks or activities may either be categorized as urgent and important, not urgent but important, urgent but not important, and not urgent and not important. Some of the things that you have to put on your topmost priority are assignment deadlines, as they are urgent and important, while some phone calls, excessive TV, or net surfing must be considered as your least priority, since they are not important and at the same time not urgent. Remember, the way you prioritize your works will determine your success now. Let these ideas sink in, and may they serve as your guide in making your to-do list. To summarize, let's not forget that if the problem illustrates a situation in which order matters, use permutation. And if the problem illustrates a situation in which order does not matter, use combination. Now, for your last activity, I want you to work collaboratively as a pair. Find a partner. Each of you must create one word problem that involves either a permutation, a combination, or both. Exchange problems with your partner, and through a TikTok video, explain the solution to your partner's problem. You may share your TikTok video with your partner and also with your mathematics teacher. Before we end our session, here are some frequently asked questions. Can all counting problems be answered using permutations and combinations? Unfortunately, not all counting problems may be solved through permutations and combinations. An example of such problem is one that involves the so-called derangement, wherein it's an arrangement of objects in which no object is placed in its original position. Second, for problems involving both permutation and combination, should we find permutation first before combination? Or the other way around? Or it doesn't matter? Counting problems that involve both permutation and combination differ when it comes to their solution. When the sequence of events may happen in any order, determining which to perform first does not matter. However, when the sequence of events follows a specific order, one must analyze whether permutation should be computed first or the other way around. For your home delight, kindly solve the following problems that are flashed on your screen. Thank you very much for joining me today in our learning expedition about word problems on permutations and combinations. Once again, this has been your math teacher for today, Sir Oliver. Goodbye for now, grade 10. Stay safe and healthy. Have a nice day.